Hello everyone. We've covered the verification V&V model. We've covered software development life cycle, software testing life cycle. We have covered what a good test case should contain, and we covered test planning, designing, and execution so far. In this training session, I will be covering the psychology of testing, just so that you understand what you need to think about while testing, and just to do a quick recap for you as to what we've covered, then we'll proceed with this training session. Now we said that in the test planning phase, which is the first phase of system testing, the management plans the high level and the low level documents for testing, and you also detail the testing activities which need to be carried out. You also create a test strategy at this level, and it's a high level management plan, and it's an approach for how testing is going to be done on this project. The test plan is a document which explains scope, the test approach, how many resources, work schedules, and is generally created by a test lead. Okay, so a test plan template, as we discussed in our previous training session, consists of the introduction, the scope of testing for this project or for this release, and what is out of scope, how we are approaching testing for this project, how many resources and their grades and designations, also the work schedule, say that you have a release which is going to be run in 3 cycles, and you have totally about 3 months for this release for testing. So you will allocate say 1.5 months for the cycle 1. We will find the maximum amount of defects, okay, and thereafter you will move to cycle 2, which is the second round of testing, where all the defects logged in the cycle 1 will be retested in cycle 2, and then you will come to cycle 3, and hopefully by cycle 3 you will have all the priority 1, 2 and 3 defects cleared out, and you can comply with your exit criteria and move ahead, right. So this is the template for the test plan. Now what is objective of the test plan? It is a document where we explain the various procedures which we are going to carry out while testing the software. Okay. Now coming to test design, okay, in this phase a test engineer or a test analyst will create test cases or test scenarios for testing the software application effectively. What is a test scenario? It is a feature or a functionality which is to be tested in the application. It is called a test scenario. Say you have a product like a calculator, okay, so what are the test scenarios for this? Scenario 1 will be check addition, scenario 2 will be check division, scenario 3 will be check multiplication, scenario 4 will be check subtraction. We also defined a test case in our previous session. So a test case is a set of steps with input data and the actual step before performed, and also the expected result. So basically it's a description of what you are testing and how you are going to test it. So for test cases you have positive and negative test cases. So when you are testing the test cases, say in a boundary value analysis theme wherein you had $10,000 to $15,000 as your range, when you test within the range, it's a positive value, it's a positive test case, it's a happy flow. Now it is for checking valid inputs. Now a negative test case is the one where you take less than boundary values or higher than the boundary value, and you test for the negative inputs. Now after your test cases are built and you go into execution, you're bound to find defects, right. So when you find defects in any tool like Quality Center, when you log a defect, there are 2 concepts there. One is severity, one is priority. Now severity is how serious the problem is or the impact that problem will have on the system. So a showstopper means you can't proceed further, your release comes to a halt because of the showstopper. The next level of severity is very high, then high, medium and low. Okay. Similarly, in priority you have priority 1, 2, 3, 4, 5 and you decide what is the priority for this defect fix, how important that defect fix is for this project in terms of functionality or in terms of the end user. Now, coming back here to this training session, that was a quick recap which I gave you earlier. We're going to look at the testing psychology and what is a tester's responsibility in any project. Okay, let's come back to the primary question, which is why test. Now, we had already looked at all these questions before, so I am sure you have the answers for all of them. Build confidence, which that is right. Prove that the software is correct. Build confidence is correct. You are demonstrating that the software is developed as per the requirements. You are going to find defects or faults. You are trying to reduce the cost by finding defects in the initial stages. The system meets the user needs and also to assess the software quality. So, that is why you are testing. Now, let us look at software quality or how much confidence you have on the project over time. So, if you plot a graph for it, okay. So, when you find a fault at a certain period of time, you keep finding defects over time and you keep eliminating defects which you found, and thereafter your confidence level increases. So, does it mean that if you find no faults or defects, is it the most highest level of confidence you have on the product? Just let's look at this statement. So, you are saying we have a few faults in the application. So, few faults means is the software highly reliable or our confidence level on the application is very high. So, if you plot something like this where test quality is high over here and software quality is low, software quality is high and test quality is low here. Now, we are saying we are here in few faults in test quality high and software quality high. Now, let us think about this for a sec. You have many faults, so then obviously your software quality is low and your test quality is very high. But instead of being in the few faults wherein you are saying software quality and test quality is high, you could also be here, right? You are thinking that you are there, but you could be here, which is your software quality is low and also your test quality is low. So, just because you did not find any defects or there were very less number of defects does not mean that your confidence on the application is very high. You have to ensure high level of test quality, thereby you will have a high level of software quality. What is the traditional testing approach? Okay, the traditional testing approach is to show that it does what it should and doesn't do what it shouldn't. Okay. So, the traditional approach says the goal is show working and success is system works. This is the fastest way of achieving it. It's an easy set of test cases. However, it results in faults being left in the application. The better testing approach would be obviously to show what it shouldn't be doing, okay, and also show that it doesn't do what it should. Okay, so your goal is find faults and thereafter system fails. Since you are trying to find faults, that is your objective. The test cases are more difficult to create, but however, you will be having a better system in the end result. Okay, what is the testing paradox which you are talking of here? What is the main purpose of testing? To find faults. Okay, now if you find faults, it will destroy the confidence you have in an application. Now, the question over here is whether the purpose of testing is to destroy confidence or to build confidence. What do you think is the best way to keep the purpose of testing as? What should your purpose be, which will ensure that you get a better reliability of the end product with you? The best way to build confidence is to destroy it. So you find the most amount of defects and ensure that you don't get any defects when the user is actually using it. So you ensure better reliability and better confidence on the system. Now there are certain rights and certain responsibilities for testers, right? So the testers have a right to accurate information about the changes, insight from developers about the areas of software. A certain level of testing should be done on the code before it comes to testing, meaning that your entry criteria should be satisfied, which is defined in your test plan. So you say that it should not have showstopper defects. For example, if you have an email application which you're testing, your login should work, your inbox should load, your contacts should load. The most common functionalities should work. It should not be a defect prone build given to you for testing. You should be able to find faults and be regarded as a professional, and you should be able to challenge specifications and test plans. You don't agree or you think there is something wrong with the specification or the requirement, you have a right to question it. And even if you report a defect which is not reproducible at all periods of time, it should be taken seriously. And you should always be improving your own testing process. Now, what is the responsibility as a tester? We looked at rights in the previous slide. This slide is discussing the responsibility. You should follow test plans and test scripts. You should report defects objectively and not point out to developers. You should check that your test cases are correct before reporting software defects. And remember, it is the software which you're testing and not the individual developers or coders who have developed the software. And prioritize what you're reporting and always communicate the truth. Now, you independently have to test your own work. Find faults in your own work before you go through and pick up defects. That's it. Thank you.